If you've ever driven an electric car, you've probably noticed a few things people don't usually talk about. The tiny vibrations, the odd hum when it's under load, and that lingering question about how reliable those high-tech motors really are over the long run. But there's an even bigger issue hiding under the surface. Nearly every EV motor on the road today relies on rare earth materials. And guess who controls most of that supply? China. That tight grip doesn't just add risk to global supply chains, it forces the entire EV industry into a corner. But what if Tesla's quietly building a way out of that? Rumors are swirling about a completely new kind of motor being developed for the 2025 Tesla Model 2, something that could change the game completely. This new design could ditch rare earths altogether, and it's not just speculation. Tesla's lead engineer, Colin Campbell, hinted at something huge during Investor Day. He said the world's shift to clean energy is ramping up demand for rare earths in a big way. But meeting that demand is going to be tough. Plus, mining rare earths creates serious environmental and health problems. So, Tesla decided to go one better. According to Colin, they've already designed their next drive unit, a permanent magnet motor that uses zero rare earth materials. If this is real, it could be the beginning of the end for China's dominance in EV technology. Don't forget to subscribe to Auto Intel and help us hit our goal of 1,000 subscribers. Tap the bell so you never miss a breakthrough like this. So what's the issue with the EV motors we use today? Most electric vehicles, including pretty much every Tesla Model 3 and Model Y, use what's called a permanent magnet synchronous motor, or PMSM. These motors are super efficient, compact, and great at delivering torque! But the catch is, they rely heavily on rare earth elements like neodymium, dysprosium, and terbium. These materials are expensive, environmentally messy to mine, and they pose a major risk from a global supply perspective. Here's why that matters. As of 2023, China controls around 87% of the world's rare earth refining and over 60% of total rare earth mining, according to the International Energy Agency. So when a Tesla, or any EV, uses a PM motor, it's ultimately tied to a supply chain dominated by one country. That's a pretty big risk, and we've already seen how that can play out. When China restricted exports of gallium and germanium in 2023, it sent a loud message. Critical materials can be turned into geopolitical weapons. If a similar ban were placed on rare earths, it could bring global EV production to a screeching halt. On top of all that, the prices of these rare earth materials are wildly unpredictable. Neodymium oxide, one of the main materials in PM motors, more than doubled in price between 2020 and 2023, jumping from about $45,000 to over $90,000 per metric ton at its peak. That kind of price swing makes it really hard for automakers to plan long-term, and those costs trickle down to consumers. Then there's the environmental side. Mining rare earths is incredibly destructive. For every ton of rare earth material pulled from the ground, the process generates about 1 ton of radioactive waste, 75,000 liters of acidic wastewater, and up to 1,000 tons of tailings, often full of heavy metals. These pollutants have caused serious damage in areas like Baotou in Inner Mongolia, China's main rare earth mining hub. That's why Tesla is reportedly working on a new kind of motor for the Model 2, set to launch in 2025. And here's the exciting part. It won't need any rare earth materials at all. If this tech works, Tesla could break free from China's rare earth monopoly, simplify motor design, and dramatically lower the environmental impact. This could be the biggest leap in electric motor innovation since lithium-ion batteries. So what exactly is a water-based motor? Instead of using rare earth permanent magnets, which are expensive, politically tricky, and tough on the environment, this new design uses electromagnetic induction powered by copper coils to generate torque. It's simpler, greener, and far more sustainable. Copper is much more abundant and spread across the globe. According to the US Geological Survey, global copper reserves top 870 million metric tons. At the center of this system is a smart cooling loop that uses a water glycol mix, similar to what you'd find in high-end data centers or liquid-cooled computer hardware. This sealed, high-pressure loop is designed to keep the motor cool even when it's working hard, improving both thermal performance and the lifespan of the motor itself. The loop operates under pressure, somewhere between 20 to 40 pounds per square inch, and keeps the motor in that sweet spot of 50 to 80 degrees Celsius, even during full throttle acceleration or uphill driving. That's a big improvement over air-cooled motors or inefficient older cooling systems. Traditional PM motors are tough to recycle because of the bonded rare earth components. This new water-based motor is modular and designed for easy disassembly at the end of its life. Tesla engineers have reportedly cut the motor's total weight by about 18% and reduced manufacturing steps by more than 30% compared to their current fourth-gen drive units. That means it's quicker and cheaper to build and better for the environment. Interestingly, the idea behind this motor borrows from two places: liquid-cooled server racks used in supercomputers and hybrid hydraulic-electric drive systems from heavy-duty industrial machines. Some of the same cooling tech used in Tesla's Dojo supercomputer, built for training autonomous driving AI, has been repurposed to keep this motor running cool and efficient. What do you think? Could this be the boldest move Tesla's made since launching the original Roadster? Drop a comment saying water if you believe this could change everything. Let's talk performance. How powerful is this new water-cooled motor? Based on leaked internal tests and industry whispers, the 2025 Model 2 could come with a water-cooled motor that delivers anywhere from 370 to 400 horsepower. That's seriously impressive for what's expected to be an entry-level EV. Most compact electric cars today max out at around 150 to 200 horsepower. Torque is rumored to exceed 500 Newton-meters, which gives it the kind of low-end power you'd usually only see in much bigger vehicles. That makes the Model 2 feel quick in city traffic and smooth on the highway. Early tests suggest it can go from 0 to 60 miles per hour in under 5.7 seconds, faster than a Toyota Camry and even some current Tesla Model 3 trims. This is made possible thanks to a 400-volt electrical system combined with that efficient and water glycol cooling setup, which helps prevent the usual power drop-off from overheating. Older EV motors often throttle performance during long uphill drives or extended high-speed cruising. Tesla's new system is designed to maintain full output longer, even in tough conditions. But it's not just about power. Without permanent magnets, you also eliminate the cogging effect, that vibration you feel from magnetic resistance in traditional PM motors. So the ride is smoother and quieter, especially during stop-and-go city driving. Internal testing shows noise levels are down by as much as 40% compared to Tesla's Gen 3 motors. The new motor is also smaller and lighter, freeing up room inside the car. That's especially helpful in a compact sedan where every inch of cabin or trunk space counts. Tesla insiders say the new design cuts total drivetrain weight by around 60 pounds, which helps improve handling and efficiency. And the best part? This high-performance powertrain is being packed into a car that could start at under $11,990. That's way below the 2024 industry average of $29,000 for compact EVs. If that price holds, the Model 2 could be one of the most affordable and capable electric vehicles ever made. Remember to hit that subscribe button if you haven't already. We're on our way to 1,000 subscribers, and your support helps keep videos like this coming. Let's tackle a big concern. Can a water-cooled motor really handle America's extreme weather? Mixing water and electronics usually sounds like a bad idea, especially when you think about Minnesota winters or Arizona summers. But Tesla seems to have solved that with what they're calling a smart coolant system. So it's got this liquid mix with some nano stuff in it that helps keep the stuff cool over a big range of temperatures. When we tested it in some cool rooms that mimic the Arctic, it actually works down to 40 degrees Fahrenheit. In places with super hot and dry air like Texas or Nevada, it can handle being at 120 degrees Fahrenheit without it boiling or going bad. The system is fully sealed and pressurized, so there's no risk of evaporation or contamination. And Tesla says it's basically maintenance-free over the vehicle's lifespan. Plus, the system uses smart sensors to monitor temperature and pressure in real time. It adjusts the coolant flow on the fly based on your speed, altitude, driving style, and even outdoor temperature. That level of control is inspired by some of the same thermal systems used in SpaceX rockets, where liquid cooling has to survive everything from outer space to re-entry temperatures over 2,500 degrees Fahrenheit. So whether you're in the snowy hills of Alaska or stuck in traffic in Phoenix, this motor is built to keep running. Now zooming out, could this be the moment the global EV industry's been waiting for? China's had a lock on the rare earth supply chain for years. That's allowed companies like BYD, XPeng, and NIO to ramp up fast and get ahead of their Western competitors. The secret? Easy access to rare earth materials, especially neodymium, dysprosium, and terbium, all essential to permanent magnet motors. But Tesla's shift to a water-based motor could be the first real crack in that armor. By eliminating rare earths altogether, Tesla gets rid of what many have called the Western EV sector's Achilles heel. And now, others are starting to follow. Ford, GM, and Toyota have all started investing in similar rare earth-free technologies, with R&D projects and patent filings showing up in their 2024 reports. If Tesla can mass-produce this in the sub-$12,000 Model 2, it might kick off a global chain reaction. This isn't about conflict, it's about independence. Getting rid of rare earths means Western automakers aren't locked into a supply chain controlled by another country. It opens the door for a more balanced and resilient EV market worldwide. So what does all of this mean for you? First, it could make EVs cheaper. Without relying on imported rare earths, Tesla can source copper and cooling tech more easily, which cuts down production costs. Some internal numbers suggest a 25% reduction in drivetrain costs alone. That helps bring the Model 2 under $12,000, less than half the average price of a compact EV today. Second, the lighter motor improves energy efficiency. Tesla's tests show a 15% boost in energy use per mile. That means fewer charging stops and more range per charge. Third, there's less to maintain. Permanent magnet motors degrade over time, especially in hot climates. Without magnets, there's no demagnetization risk. Cooling is better, torque is smoother, and parts last longer. Fourth, it fits real American budgets. Whether you're on Social Security, commuting from a rural area, or just trying to stretch every dollar, this could be the EV that actually works for you. And finally, it's built for all climates, from freezing winters to blazing summers. So no matter where you live, this motor is built to last. If Tesla's new water-based motor performs like they say it will, it could finally cut the cord from unstable global supply chains and make electric vehicles truly accessible for everyone. This isn't just a technical upgrade, it's a turning point. Would you trust a water-based motor over rare earth magnets? Let us know what you think in the comments. And don't forget, subscribe to Auto Intel and help us hit 1,000 subscribers. Tap the bell so you're always first to know when game-changing tech like this drops. I'm Danny, and I'll see you in the next one.